Panel objects are used to implement both web applications generated in Angular and applications generated for mobile devices in Android or iOS. That's why the events available in this object are mostly valid for both platforms. In this video, everything about events in a panel object will be applicable to both types of platforms. Exceptions will be explicitly made where appropriate. A panel object includes two types of events, those triggered on the client side and those triggered on the server. Server events are the same as when working with web panels: start, refresh, and load events. These events will always be triggered on the server for Angular applications and online native mobile applications. When implementing offline native mobile applications, they'll be triggered internally on the device. The client-side events are client start, back, user-defined events, events associated with the screen controls, and also the events predefined by the work with pattern, which allows generating a series of panels that work with an entity. This is in order to make additions, modifications, deletions, data navigation, filters, and so on in an analogous way to the work with pattern we use when working with web panels. When the panel objects are used to generate an application for mobile devices, we will have the events associated with the information navigation styles, which depend on, for example, the type of device and its orientation when the application is started. Now, let's see the server-side events. The first one executed is the start event. It's executed only once, when the panel is opened, and will not be executed again unless we exit the object and reopen it. The refresh event is executed after the start event, usually only once, but it can be invoked again using the refresh command. In that case, it'll be executed more than once and will be the first event, since start will not be executed again. When the refresh event is invoked, the load event will be triggered at the end. This will only happen if there's at least one grid in the panel, and the grid is not a collection SDT variable. The load event is the last one of the system events to be executed. If it has a base table, it'll be executed as many times as records exist in the base table. If the grid does not have a base table, it'll be executed only once. And if the grid is based on an SDT, the load event will not be executed. In the case of an application for mobile devices, the code of the start, refresh, and load events has no access to the device's resources, such as camera, GPS, and so on. Let's consider the case of the following panel, which allows viewing a grid of attractions and filtering the grid by country and attraction name. The grid contains the attributes attraction ID, attraction name, attraction photo, city name, country name, and a trips variable that will show the trips made to each attraction. Below the grid, we can see the overall total number of trips made to all attractions. We can also see the model of the transactions used in this panel, and the grid conditions that allow performing the filters. The start, refresh, and load events that are triggered on the server side are programmed in the Events tab. In the start event, we're loading the text blocks that show the title of the panel. In the load event, we calculate the total number of trips of an attraction by means of a formula that accesses the trip attraction table, corresponding to the second level of the trip transaction. Note that in the count formula, we're referring to the trip date attribute, and, due to the attributes present in the grid, the base table of the grid, that is, of the variable part of the panel, will be trip attraction, so the trips corresponding to each attraction will be counted. In the refresh event, we program a for each to access the trip attraction table to count the overall total number of trips of the attractions. As a result, when the fixed part is drawn, the data corresponding to the total number of trips is already available. Now, let's see client-side events. These events are the application's response to user interaction. There are several types of client events: system events, such as client start and back, user events, on-screen control events, and others that we'll see next. The code associated with these events is executed in the client, unless access to a server resource is requested. For example, if you want to access the database. In this case, the client will have to invoke a server service. During the execution of a client-side event, server-side events are not executed unless explicitly requested through the refresh command. This causes the server's refresh event to be triggered, followed by the load event, if there's at least one grid, as we saw before. When running a native application for mobile devices, client-side events have access to all hardware and software resources of the device, such as the camera, the GPS, the microphone, calendar, contacts, and so on. These client-side events will have a specific grammar that's different from that of server-side events. In particular, when it comes to concatenating more than one action in an event, a special command called Composite must be used that will be discussed later. Let's take a brief look at each client-side event. The client start event is the first event to be triggered, even before the start event that is triggered on the server, and with no need for any user interaction with the application. It's used to initialize the home screen and UI-related aspects. The back event is used on mobile platforms and allows you to capture that the user has pressed the back button on Android devices, or that the back gesture was made on iOS devices, and then program an appropriate action. User events have a name given by the user, and allow the developer to associate a certain code to be executed when a certain on-screen control is activated by clicking or tapping on it. On-screen controls have their own events, depending on the control involved, such as click or tap, double-click or double-tap, drag, swipe, control value changed, and so on. These events are triggered when some of the above actions take place, and the developer can program a response of the application to the user's interaction. The work with pattern has predefined events that are triggered depending on the action performed on the data of the entity to which the pattern is applied. These include the insert, update, delete, save, and cancel events, among others. The events available will depend on the part of the work with object being executed, list, detail, and so on. In the case of mobile devices, depending on the type of device and orientation, when we start the application, a start event will be triggered depending on the navigation. For example, if we're using a tablet, by default, the application starts in split mode, meaning that the screen is divided into two sections, with a list on the left and the detail of the selected item on the right. In this case, when the application starts, the split.start event is triggered. In the case of phones, for example, the screen will show only the list, and a separate screen will be opened to view the details. This mode is called flip, and is the default behavior in these devices. Therefore, when starting the application, the flip.start event will be triggered. Although there is a default navigation for each device, the main objects of mobile applications have a property that allows changing the way the application starts. These start events associated with the type of navigation are triggered at the start of the mobile application and immediately after the client start event. In the object we saw before, we program only events associated with controls. We don't program any user events. To each variable of the on-screen filters, we program its control value changed event to trigger the grid refresh method, which will cause the server refresh and load events to be triggered to update the contents of the grid with the filters entered. In short, Let's see what can be done in a client-side event. We can invoke another panel object. We can also invoke REST services. And when we invoke procedures or data providers, they'll automatically be exposed as REST services on the server. If those procedures or data providers were invoked only from a server-side event, within start, refresh, or load events, they would not be exposed as REST services because they would not be necessary. Use business components to retrieve or update information. In this case, these business components will also be exposed as REST services automatically. It's possible to directly invoke any node of the work with pattern. In mobile applications, we can invoke a menu object. We can invoke the external objects defined in the Genexus module. Some of these APIs only make sense for a particular platform, such as mobile devices. Meanwhile, some of them can only be used on web applications, and others can be used on both platforms. To find out which ones can't be accessed by Angular applications, we invite you to visit the wiki page shown on screen. We can also call subroutines. In addition, we can assign properties to controls, assign simple or SDT variables, run for each line and for each selected line on grids, use the blocks if-else, do-case, and do-while. If we try to use commands not allowed in a client-side event, we'll see an error in the output screen for those lines that don't comply with the grammar constraints. For example, if we try to use a for each command, a new, or any attempt to access or modify information that's only accessed from the server. Here's a summary of the commands we can use in the client-side event code. These restrictions are only for client-side events, but not for server-side events. Start, refresh, and load, where we can use all commands and functions available in Genexus. As for commands, the accepted ones are shown here. Now, let's look at the composite command we mentioned before. This command is used in panel objects on client-side events when 2 or more lines must be written in an event. In this case, it's mandatory to group the complete event code inside this command. This command is important because if an error occurs in the call sequence, it stops running, and the errors are automatically handled and displayed on the screen with no need to implement any programming. It's a great difference with web panels, because when a called object in an event causes an error, the execution is not interrupted. It continues in the following statement, and the developer is responsible for handling the errors and programming the actions to be taken. Now let's see what happens with events when we run a panel object. The client start event is executed first, and it's executed only once on the client. In mobile applications, the start event corresponding to the type of navigation set in the main object is then triggered by means of the navigation style property. Next, a data provider is executed that will return the data needed to load the fixed part of the panel. This data provider is involved in the execution of the code of the start and refresh events to be executed on the server, and returns, in a single result, the information to load the fixed part. The fixed part of the panel is drawn later. Then, a second data provider is executed that will retrieve the data required by the grid. Within the execution of this data provider, the load event code is executed on the server. This load event will be executed n times when the grid has a base table. Once for each record, only once if the grid doesn't have a base table, and not at all if the grid was from a collection SDT variable. At the end of the execution of the data provider, it'll return the information generated by all these executions of the load event in a single result, which will be used to load the grid and then finish drawing the grid. We've mentioned that the fixed part of the panel is loaded independently from the loading of the grid. Different data providers are invoked that are published on the server as services and access the database to retrieve the information of each part. When we change the value of a filter, the grid's information needs to be refreshed. For this, we need to add the grid's refresh method, which will trigger the server's refresh and load events. In turn, it'll cause the grid to be reloaded, applying the program conditions and displaying the filtered results as expected. Since the grid's refresh command must be invoked after we change the value of the filter variable, we use the control value changed event of each variable to invoke the method. In this way, after changing a filter value, when leaving the field, the corresponding event will be triggered, which is expected to refresh the content of the grid. But what happens when the refresh command is invoked within a client-side event? In this architecture, since the objective is to have the page loaded as few times as possible, the data cache is prioritized. That is to say, we always try to retrieve the information previously saved. That is, depending on the caching configuration, it's decided whether or not to go to retrieve data from the server. When it's decided to go to the server, if there are no changes in the server data, nothing is returned to the client. Otherwise, the refresh and load events are executed, if there's a grid not based on an STT, as in our case, and the fixed and variable parts of the panel are updated as expected. For the server to understand that we want to bring new data, the URL sent to the server must be changed, so that it understands that it's a new page and obtains the corresponding information to send to the client. To do so, we add a parm rule containing the values of the variables used in the filters. In this way, if a variable's value changes, the page is updated with the new data. We run the panel to test what we've seen. We see that with empty filters, all the attractions are shown. And for each attraction, the total number of trips is correctly displayed, calculated in the load event that updated the grid information. In addition, the overall total number of trips that is in the fixed part is shown correctly, since it was calculated in the refresh event, and was executed before the fixed part was drawn. If we now choose the attractions of the country France, and choose to see the attractions starting with the letter H to the letter N, the value of the filters included in the grid conditions works correctly. Also, the invoked refresh commands caused the refresh and load events to be triggered. So, the information was correctly updated when retrieved from the server, and we only see the attractions of France with the name in the chosen range. The following videos will discuss other aspects of the design and implementation of panel objects.